Hello, I'm going to talk about polarization of light. Polarization of light. Polarization in Chinese is 极化. Okay, so if we consider a light, a ray that has electric field, so this is electric field here. Okay, and it has a direction. So if you look at x and y, you see it has component of ex and ey like that. Okay, and now this is a polarized ray, polarized light. So you only have one direction. So this is single direction. Okay, now if you look at unpolarized light, then you have all directions, So I only draw 1, 2, 3, 4, but it has all directions. Now, if I have a polarizer and I represent it as like this, like a grill. So when you go through this, only this E in this direction will come through. Okay, but think about it. If you have an arbitrary E field like this one here, the component of this side here still pass through, and just this side here doesn't pass through. Okay, so from that you can it's kind of makes sense that once you go through here, your intensity will become half of it, because for any directions, the light that with electric field in any arbitrary direction, there's always component that's along the direction of the polarized or aligned with the polarizer direction. But the other direction, it's being blocked. Okay, so this one here will be blocked. And this one here will go through. Okay, so you can imagine that when you go through a polarizer for unpolarized light, it will become half of intensity, and this I is intensity here. So intensity is brightness, of light. Okay, so as we recall from earlier, intensity is equal to epsilon 0, the permittivity, times the speed of light, times E squared. So electric field's value, the magnitude of electric field squared. Okay, now if we consider a light with electric field going in this direction, now if the polarizer is not aligned but with a theta like this, so then you can decompose the E field into E cosine theta and the E sine theta. So the E sine theta will be blocked. So this will be blocked. So only the E cosine theta will go through. And so we'll have E prime is equal to E cosine theta left. Now, if you go and look at the intensity, and we call this formula here, and now I prime after the polarization is epsilon 0 C E prime squared. And E prime is equal to E cosine theta. So that's square that, it becomes E squared cosine squared theta. And this is your I right there, original I. So now you have a cosine squared theta. So now you have I prime after the polarization, it's equal to I times cosine squared theta. So that is the basic of polarization, how polarization works. So if we give an example, if you have a polarizer that goes like this, and then you follow that with another polarizer that has direction like that. So this is polarizer one, and this is polarizer 2. Okay. So now if you have an unpolarized light, okay, so then you have this. We can also draw it this way too. So this is unpolarized light. Okay, so when you go through this, right, it will only have this E field that going this way now. Okay, And now you can see this one here is 90 degree to this polarization direction. So then nothing will come out. So then you have nothing here. Basically, you are dark. You have nothing. So this you can also using I, or you can using E prime, right? So E prime is equal to E cosine theta. And theta is 90 degree, right? So this is this, right? So the direction of this one versus this one here. So that is 90 degree. And that's your theta right there. So then cosine 90 degree is equal to 0. So then this E prime is equal to 0. So certainly I prime, which is equal to I times cosine squared theta, according to the previous page, this is equal to I times 0 squared, which is also equal to 0. You can see this will be dark. Okay, so that's what we have today. We talk about polarization, and it's useful in the sunglasses. So in the case of sunglasses, if you wear sunglasses, okay, and let's say if you unpolarized light right here from the sun. So this is from sun, and it's unpolarized. Unpolarized. Okay, so it's coming through here. Then at this side, if this one here is, let's say, in this direction. So basically, you will have I here, and then once you reach your eyes, right? Your eye is right here. Okay, that's your eyes. Then you will only see half of eye. So you can see now you have received less light and hopefully less damage to your eyes. Okay, yeah. So that's all we have. Thank you for watching. And if you enjoyed, you're interested, keep watching and subscribe to it. Okay.